Good morning, welcome to new lecture. Today I will review several examples regarding influence line in beams. Let's look at the first one. We have this beam. Point A, B, C, D. We want to draw influence line for moment at point B. Influence line at point B. First step, I should cancel or remove internal moment here at point B, so I should put one hinge over there in my brain. Then I should apply this kind of rotation. If I apply that rotation, AB part will not rotate. But if I apply this rotation, BC part will rotate. So, the form shape for a structure will be this shape. If this is, for example, 3L, this is L and L, because only one side can rotate, this angle will be 1 radian, it will be unit angle. So if from here to here it is L, this height will be L as well. So this will be moment influence line at point B. Let's look at the next example. Assume we have this. A, B, C, D. We want to draw a moment diagram again at point B. Pay attention to the details here. Here, this beam is continuous and it passes over this hinge, and here we have shear connection. So this kind of support we will have bending moment but no shear force or force reaction. So if I want to draw moment influence line for this beam, I should put hinge here, apply rotation here. Again, if I apply rotation, this side will not rotate, so we will have the form shape for structure. And if from here to here it is L, L and L, because this angle should be unit angle 1 radian, so this height will be L. Next example. We have this beam. A, B, this is shear connection C, support D, support E, point F, and length L, L, all of them, it is L. This one, it is shorter, and the length for this one it is L over 2. This beam is subjected to the moving load, uniform distributed moving load. The intensity of the load it is W, and the length for this it is equal to L. So the intensity of the load it is W, but the length it is L, and this is traveling load. It will travel from A to F. We want to find location of this traveling load so that we make moment at point C maximum. So where we should put this moving or traveling load on this beam in order to produce maximum internal moment at point C. So we should draw moment influence line at point C because we want to find maximum moment at point C. Here we have shear connection. If I add hinge, so I should add hinge this side and cancel internal moment over there. And then I should apply rotation in this direction. If I apply rotation in this direction, this part cannot rotate. You see, this is continuous and we attach to the ground using two supports. So that part cannot rotate. We will not have any rotation in that side. But BC part can rotate respect to the B, and it will move up like this. Then AB part again will remain horizontal. So this will be influence line for this beam at point C. Influence line for moment at point C, because this angle should be equal to unit angle. If this is L, the height should be L. Now it is clear where we should put this traveling load. If we put traveling load in the span of BC, in this span, the maximum moment at C will be intensity of that load times area underneath of that load in influence line. It means area for this triangle. The area for that will be L times L divided by 2. This will be WL squared over 2. So if we put that traveling load at BC span, we will have maximum moment at point C, and the magnitude of that moment will be WL squared over 2. Let's look at to the next example. A, B, C, D, E, F, LL, 2L, L, 2L. We have one moving load. The intensity of the load, it is uniform distributed load. The intensity of load, it is W. But the length for this load, it is variable. It can have any length. So where we should put this moving load or traveling load in order to have maximum moment at support A. Because we want to find maximum moment at support A, I should draw influence line for moment at point A. So, point A, I will put hint, I will apply rotation. This side it is ground, no rotation. So this side will rotate. AB part will rotate respect to the A. From B to D it is continuous, so that part will rotate respect to C. DF part it is continuous, it will rotate respect to E. This will be influence line. And because one side rotating, this angle will be 1 radian. So this is 2L. So this height should be 2L in order to have this angle equal to the unit angle. From similar triangle, you can find this height will be 4L and this height again will be 4L. The load, it is traveling load and the length is variable. Let's see where we should put to have maximum moment at point A. The area from here to here, it is negative, positive, negative. The area from A to C for influence line, if we put load from A to C, will be 2L, the height, times the length, 3L, over 2 times W. We will have 3L squared W, the moment at point A. If we put from C to E, area from C to E in influence line will be 4L, the height times 3L divided by 2 times intensity of the load W, it will be 6WL squared. If I put from D, E to the F, I should find the area for here, it will be 4L times L divided by 2 times W. It will be 2L squared W. So which one is bigger? This one is bigger. So I should put this distributed traveling load from C to E, and the length of for this uniform distributed moving load should be 3L. If the length of this load it is 3L, I put here, we will end up with maximum moment at point A, and the maximum moment will be 6WL squared. Next one. Next example is this example. A, B, C, D, E, F. The length for each segment, it is L. Of course, I didn't draw by scale, so sorry. Maybe it seems different, but all of them are equal L. We want to draw influence line for moment at point D. So influence line for moment at point E here. So I will put hint, I will apply rotation. If I apply rotation, what will happen? From D to the F, it cannot move. So from D to the F, it will remain like this. Then this part will rotate respect to the C. So it will go like this. Because this BD part is rotate respect to the C, so the AB part should move down, and it can move down because of this kind of connection, freely can move down. So this will be influence line for moment at point D. So this will be negative, negative, positive. Okay, let's look at the next example. A, B, C, D, E, F, G, H, I. Length 2L, L, two L, 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 2L, L, and L. We want to draw influence line for point E. Influence line for shear at point E. So the influence line for shear force at point E, because E it is hinge, we cannot draw influence line for moment. Definitely we should draw influence line for shear, because there is no moment already. We should draw influence line for those forces we have in that system. So we will draw influence line for shear at point E. This beam is subjected to moving load. The distributed load intensities W and the length is 2L. We want to see where we should put this moving load in order to end up with maximum shear force at point E. So if we draw influence line for shear at point E, what I will do, I will apply this kind of connection at point E. Point E, already we have hinge here. Let's look at now. If I want to draw shear force influence line, I should cancel shear force too. So I should convert this to this kind of connection. Now, this side should move down, this side should move up. Let's see How it is possible? If I move this up, this should rotate respect to the F. It cannot rotate, you see, there is no, it is not possible to rotate this piece respect to F because it is continuous part, and here we attach using the support to the ground, here we attach it using support to the ground as well. So this part cannot rotate. And even this part, it is discontinuous, you see the hint. So anything happens in this side of the G, in the left side of the G, there is no relation between left and right because of this hint. So here there is no movement until this point, point E. It will not move and it will remain horizontal line. Now, if I move this down, this part will rotate respect to the D. If this part rotates respect to the D, in this kind of connection, after rotation, the left side and right side should be parallel. So this piece should move down and these two parts should be parallel. They should have the same slope. AB part, because it is fixed, there is no movement. It will remain horizontal. So this will be shear force, the influence line at point E. This will be unit because one side only can move down. So this will be 1. If this is 1 from similar triangle, you can find this will be 2. And because these should be parallel, this line and this line, so this should be 1. Now, where I should put that load, you see we should put that load here. If we put that load here, this is the biggest triangle we have. Area for this triangle times the intensity of the load will give us the maximum shear force at point E. Pay attention always in this kind of connection. If it rotates one side respect to one hinge, another side should be parallel. Let's look at the next one. Next one, again it is one continuous beam. Okay, for this beam, we want to draw moment influence line at point B. Moment influence line at point B. Let's see. First, I should remove internal moment there. So I should put one hint here. Then I apply this rotation. If I apply that rotation, AD part can rotate respect to A. BD part can rotate respect to the C. This angle should be unit angle, 1 radian. And this will be AB over L. This height A is 1 times 2 over L3 will be 2 over 3. From similar triangle, you can find this is again 2 over 3, positive, negative. We have shear connection here. Left side and right side should be parallel. So this will be this part, DF part, will rotate respect to the E, and this part, if this DF part rotates respect to the E, point F will move down, so this part should move down too, and it can move down, because again this is shear connection, left and right should be parallel. So here we have ground, and horizontal line, it is parallel to the ground, so that is possible movement. So we will have G, F, E, D, C, B, A. From similar triangle we can find all these. This will be 2 over 3, 2 over 3, this will be 1. This will be negative 1 and negative 1, because these are positive, negative, negative. I think for today it is enough. Next time I will solve more examples and I will cover influence line for girder and trusses. This is influence line for beam. Then next topic, it is very similar, a little bit we will modify this solution for girder and truss. If you understand the concept, we will apply the same concept to the truss. So for next session, I will review more example and I will cover influence line for girders and truss. Thank you, trusses. Thank you so much for watching this lecture. See you next session. Bye bye.